All right, good morning. Got another warm up. Let's tackle it. See how we do here. All right. I want to remind you this is one of those order of operations problems. What do you do first in order of operations? Oh. Remember, parentheses comes first. Doesn't matter if they're the simple parentheses, they can be the fancy ones, they can be the big brackets. You always do that first. After you're done with that, you're doing exponents and square roots. That's like your grandma. You let her take cuts in front of everybody, but unfortunately, whether you like them or not, the president gets to take cuts in front of grandma even. But you're fighting for her, right? After grandma, we have what's more sophisticated, girls or boys. Ladies, you go first. Okay, ladies are more sophisticated, so that's going to be like times, multiplying, and dividing. And if there's both, multiplying and dividing, you're going to go from left to right, kind of like you read. And the last thing you do, the simple boys, your last, subtracting and adding. And adding and subtracting, whichever one is on, comes first, goes first, right? But you're not going to do any adding and subtracting until you're done with everything above it. Okay. All right. Copy this down. Let me zoom in a little bit. Have you copy down that top part. And then I'll raise it up and let you copy down the bottom part. Go ahead. Pause. Okay. Now let's copy down that bottom half of the problems. Remember, we're doing these fractions where I think eventually you'll be able to do these in your head. A little bit of practice, especially if you know your facts for sure. If you don't know your facts, practice your facts. It'll be that easy once you learn your facts. Okay. All right. You've paused it. Now go try these problems, and then we'll come back and go over answers. And it's time to go over some answers. Let me see. I got 75 up here, 17.5. Can that work? These are challenging today. I haven't put a star next to that one. That's a double bonus. You get that one. So what's this going to be? 75 and 17.5? Check this out. 10 times 7 and 5/10. When I go add those, where's the decimal in the 10? Right here. So when I go add those, I do get 17.5, right? You might put a 0 here before you add. When I multiply, remember how I've been telling you that your teachers last year and the year before, when they said to add a 0 when you multiply by 10, I say stop doing that because we want to be able to multiply decimals now. So start learning to move the decimal over a spot. So like 8 times 10, you're not going to say 8 with a 0 now. You're saying 8, move the decimal over one spot, and then add the 0. Okay, now why are we doing that? Because now you can multiply decimals. 10 times 7.5 is move the decimal over one spot because there's 1 0, 75. Isn't that easy? Okay, and you could divide, right? If you had 2.4 divided by 10, I move the decimal over that spot, that way one spot, 0.24. Pretty cool. And same thing with 100, 1,000. Okay. 4 and 8/10, 6 and 8/10. What do we got here? We got 6 and 8/10. 6 times 8 is 48, but I'm going to move it over one spot because I moved it over one spot in my problem. I've got to move it over one spot in my answer, the opposite direction. Okay, and I add 6 plus 8/10. Where's the decimal in the 6? Right there. 6.0 is the same as 6, right? Whoops, 0.8. Add that, and I get 6.8. How about 17 and 52? You want a hint? Want a hint? Deck of cards. 4 times 17. Nope. 4 times 13, right? Ace through 10. Jack, queen, king. 13 in each suit. There's 4 suits. 52 cards in the deck. 4 times. Or you could think 4 10s, 40. 4 3s, 12. 40 and 12, 52. And then 4 plus 13 is 17. Now, this is a double bonus one. Why? This is hard, right? What are we doing here? Well, here's where we have 1/2 and 3/10. 1 times 3 on top, 2 times 10 on the bottom. When I add these, I have 1/2 is the same as 5/10. 5/10 and 3/10 is 8/10. But you said it's supposed to be 4. We can simplify. 2 goes into the top 4 times, goes into 10 5 times. All right, let's do this problem. Okay, we want to remember that, I got to do parentheses first. There is no parentheses. What do I go? Exponents and square roots. I should have, right? Square root's the opposite of to the second power. So any exponent square roots, and I have square root of 9, 4 cubed, or to the third power, and the square root of 64. When you get the square root of 9, you're saying what number squared equals 9? What number times itself equals 9? 3. And 4 to the third power is not 12. It's 4 times 4 times 4. 16 times 4. Don't get 48 on that. Don't say 16 times 3. It's 4 times 4 times 4. So 16 times 4 is 64. What's that backslash mean again? Divide. But now I got to figure out what is the square root of 64? What number squared is 64? It's not 32. That's half. We want a number multiplied by itself. And that ends up being 8. The square 8 to the second power is 64. That's 8 squared is 64. So the square root of 64 is 8. Now, what do I have left? I have adding, multiplying, subtracting, and what's that mean? Divide. So I got to multiply and divide before I do any adding or subtracting. Okay, what is the product of 4 and 3? 12. So I have 16 plus 12 minus, what is the quotient of 64 and 8? How many times does 8 fit into 64? Okay. Now all I have left is adding and subtracting. And what do I do if I have both? I go from left to right. So I'm going to do 16 plus 12, 28. And what is the difference between 28 and 8? 20. Very good. How'd you do? And again, if you got this wrong, that's okay. If you can find where you went wrong. And you see how I solve it. Don't be afraid to rewrite things that you already know. Okay? Don't skip steps. I can trace every single number. 20 came from 28 minus 8. Where did 28 come from? 16 plus 4. Where did 16 come from? From here, from here. How about the 12? 4 times 3. Where did the 3 come from? Square root of 9. Right? All of these numbers I can trace. Okay, that's what you want, because then if you make one mistake out of all those different steps you had to do, you can find it, and that's where you learn. All right, 2 to the fifth, 2/5 to the third power. That's 2/5 times 2/5 times 2/5, right? 2 times 2 times 2 on top, 5 times 5 times 5 on the bottom. 2 times 2 times 2 is not 6. 2 times 2 is 4, times 2 is 8. 5 times 5 is 25 times 5. Don't get 75 on this. 5 times 5 is 25. You don't multiply it by 3. It's 5 times 5 times 5. It's 5 times itself 3 times. So 25 times 5. Did you get that? All right. How about 3/4 squared? That's easier, right? 9/16. 10 to the third power. That is a 1 with 3 zeros. 5 to the third power, we already figured out. It's 125. But can I simplify that? Well, check this out. 10 over 5 is equal to what? 2, right? So really, this problem could be 2 to the third power. We already know that's 8. Well, guess what? 125 goes into 8. I mean, 8 times 125 goes into 1,000 8 times. Let's just prove it here. 8 times 5 is 40. 8 times 2 is 16 plus 4 is 20. And 8 times 1 is 8 plus 2, 10. So this simplifies to 2. I mean, to 2 to the third power, to 8. Okay, 8 over 1 is 8. Okay, so even if you didn't do that parentheses first and simplify it, when you could, you get the same answer. All right, area and perimeter. The area is how wide it is times how tall it is. That's going to be 5 times 2x plus 1. Well, guess what? This is set up to just do, okay, the generic rectangle. Okay, I want to do 5 times 2x plus 1. 5 times 2x is 10x. 5 times 1 is 5. So my area ends up being 10x plus 5. And I want to write square units. We don't know what the units are, right? Now the perimeter, 5 plus 2x plus 1 plus another 5 plus another 2x plus 1. So total, I have how many x's? 4x plus 4, 2x plus 2x equals 4x. And then 5 plus 1 plus 5 plus 1 equals, is that 12? Yeah. So the perimeter equals 4x plus 12, just regular units. Kind of a weird problem, huh? It's all right. Planting some seeds that we're gonna grow later. Oh, could you see that over there? Could you see that over there? 5 times 2x plus 1. 9 times x plus 3. I just changed that to an m. Yeah, it's planting some seeds, right? Always thinking ahead for you guys. All right, the perimeter of this, m plus 3 plus 9 plus m plus 3 plus 9. And again, if you wrote this out, m plus 3 plus 9 plus m plus 3 plus 9, the next thing what you're doing is you're grouping what goes together. What can I put together to simplify? And what they call that is combining like terms. You're putting the x's together, the y's together, the m's together, the z's together, and the numbers together. The numbers are called constants here. So a 3 and a 9 and a 3 and a 9, that's a 12 and a 12. That's 24. And then I got an m plus an m. That's the same as 2 times m. So 2m plus 24 units is the perimeter. Now the area, 9 times m plus 3, right? Let's do m here. Oh, I can't do it. I messed up there. Let's rewrite it over here. M plus 3 and 9. So I'm going to have a 9, and I'm going to split this up. Whoops, I'm still doing it wrong. M and 3 here. So 9m plus 9 times 3, 27. Okay, and what you're going to eventually learn is this is 9 times m plus 3. Something's called a distributive property. This is 9 times m plus 9 times 3. Okay, all right, don't worry. We will go through that some more. So the area equals 9m plus 27 square units. Okay, all right, almost done here. Now it said same answers, but pretend x is 4 and m is 1.5. If x is 4, what am I going to do here? I'll substitute. The perimeter is going to be 4 times 4 plus 12. 16 plus 12 equals 28 units. The area is going to be x equals 4. 10 times 4 plus 5, 40 plus 5, 45 square units. 2m plus 24. If m is 1.5, that's 1.5. So 2m is 3. 3 plus 24. The perimeter is 27 units, 24 and 3. If m equals 1.5, I got to go 9m plus 27. And we're saying m equals 1.5. I'm going to substitute. Go 9 times 1.5. Pretend there's no decimal. 45. And then I'm going to move it over one spot. So this is being 13.5 plus 27. 13 plus 27 is nice, even 40. So it's going to be 40.5 square units. All right. All right. On to these, being able to do these fractions in your head. 1/3 of 21. Now you could say of means multiply. Put a 1 under the 21. Multiply across the top. Multiply across the bottom. and then simplify. 3 goes into the bottom once. It goes into 21 7 times. 7 over 1 is 7. Or you can just think to yourself, a third of 21 is 7, right? 21 divided by 3. If 1/3 of 21 is 7, 2/3 is going to be 2 7s. 7 plus 7, 14. 5/3 is going to be 5 7s, 35. 1/8 of 32, I'm doing this in my head, is 4. 3/8 equals 3 times 4. 12. 1/5 of 30 is 6, right? 3/5 is going to be 3 times 6, 18. 1/9 of 27 is 3. 4/9 is going to be 4 of those, 12. Okay, last two. Now we're estimating. Now, when you're estimating, your job is to make it easy. So, do I want to round this to 25? Do I want to round this to 30? No. 30 makes it easy, but 27 is right next to 26, and I know 3 fits into 27. How many times? 9. So 1/3 of 26 is about 9. A little bit smaller, right? Because it's 27 is exact. 1/4 of 46, well, instead of changing this to 50, or 4 doesn't go into 50, I want to change this to, you have your two choices here. You can say 48 or 44. They're 2 away from each, and they're both easy, right? 4 fits into 48 12 times. If you change it to 44, you'd say 11. So 1/4 of 46 is going to be somewhere between 11 and 12. Both of those are good estimates. Okay. All right, you guys. Have a great day. Be nice to your teachers.